Here's my plan.
All right, so we have chapter 4, section 1, day 5. We're doing the word problems. So in the book, it's example 6 on page 224. And so it looks like this, and gives us a picture that we're going to draw out from this problem. It says, a ground crew worker who is 6 feet tall is directing a plane on a runway. If the worker sights the plane at an angle of elevation of 32 degrees, what is the horizontal distance from the worker to the plane? So when you're setting up your picture, you don't have to have all the details of like actually drawing the airplane. We know it's right triangle trig, so we know we're going to have a right triangle. But figuring out where everything goes, if you start with the ground, because most of these questions, you'll have the ground involved. And you know where the ground is. The ground, generally, is right here on the bottom. And the guy is probably going to be standing on the ground, most likely. And then the airplane is up in the sky. And the ground worker, it tells us he is 6 feet tall. So I'm going to label, ooh, that's a feet, 6 feet. He's 6 feet tall. And he is looking up at an airplane. And the airplane is directly above the ground. So we know that from the airplane to the ground is 150 feet. But the angle of elevation is 32 degrees. Angle of elevation is from his eyes. And if he's 6 feet tall, that means the bottom of the triangle is not the ground. So the bottom of the triangle, we have to do... So there's the bottom of the triangle. Because it's where his eyes are. And then he's looking up 32 degrees to the airplane. So angle of elevation is from the horizontal and is 32 degrees. So that means the side of the triangle is not 150 feet. It's 150 to the ground, but the horizontal is 6 feet above the ground because the man is 6 feet tall. All right, so we have to figure out what is this distance on the triangle. What is this length on the triangle? So we know we have
144.
Yes. We subtract his height from the height of the airplane. It gives us 144. So this is 144 feet. And we are looking for the horizontal distance. So that means the x is going to be right here. And now we can label the parts that we need for our trig. So here's the angle. The side opposite the angle is the opposite side. So there's my opposite side. The leg of the triangle that touches the angle is the adjacent side. And the third side of the triangle has nothing written on it. I don't care about it, so we're not going to put anything there. There's nothing there. His line of sight. We don't even need that part. So this is opposite and adjacent. When it's just the legs of the triangle with no hypotenuse, you're going to use tangent, because TOA, tangent equals opposite over adjacent. So tangent of the angle, and we have the angle, it's 32 degrees, is equal to the ratio of the opposite side, 144, over the adjacent side, x. All right, so then we can use trig, we can solve the trig equation. So I showed you the algebraic steps for getting x out of the denominator, and I showed you that the shortcut summary that x and the trig function are going to trade places. So then x equals 144 divided by the tangent of 32. And as long as you're in degree mode, you can just type that in the calculator, and it should give you the value that x equals 230.448 feet. So the guy is standing 230.44 feet away from where the airplane is. All right. And then I have one more example.
Is that where you want it to round it to?
It doesn't say for this problem what to round to, and they're all different, but each problem in your assignment should tell you what to round to.
Okay.
I went with 3 because College Board does 3 for AP, so I did 3 spaces.
Okay.
All right, so example 7 is on page 225. This one is a hot air balloon question. It says a hot air balloon that is moving above a neighborhood has an angle of depression of 28 degrees to one house and 52 degrees to a house down the street. If the height of the balloon is 650 feet, estimate the distance between the two houses. All right, so we have to just set up a picture. We know our picture will involve right triangles. And we're in a hot air balloon this time, so it has a little basket. And then there's a balloon with some little strings. There we go. So there's the hot air balloon. It is above the ground, so here's the ground. And from the hot air balloon, he's looking at two houses, the person in the balloon, right? So this time we can use the ground in our triangle. That's fine. There's nothing above the ground. So this will be 90 degrees. And the person in the balloon is looking at two houses. And if it's an angle of depression, if it's an angle of elevation or depression, you need a horizontal in order to draw it. So we're going to sketch a horizontal line so that we can put in the angles of depression. Oh, we know the height to the balloon is 650 feet. That was given in the problem. And we're asked to find the distance between the two houses. So we want this distance. And I'm going to represent, it doesn't matter what letters you use, but since I already did it and used Y, I'm going to use Y, just so I don't mess up with what's on my paper. So I'm going to call that distance Y. And I have an angle of depression to the first house. So from the horizontal, looking down, is an angle of 28 degrees. And that's the first line of sight to this first house. That angle is not inside the triangle. So I'm going to use the property of alternate interior angles are congruent. So I have parallel line, and a transversal cutting the parallel lines. So on this transversal, I can alternate sides, and these two angles are congruent. So I can move it here. It has to be the same. 28 degrees. And then I have another one from the same place, the person in the balloon, angle of depression from horizontal going to the second line of sight is 52 degrees. So if this angle on the top of this line is 52, I can alternate to the other side and say that this must also be 52 degrees. Okay. So we have two right triangles here. There's the big right triangle that goes to the first house that I did in green. And then there's a second right triangle from the balloon with the second house. We can't use this obtuse triangle between them because it's not a right triangle, so we can't use right triangle trig with that. But if we find the distance to the farthest house and then the distance to the closer house, and we subtract that would be the distance between them. So I'm going to do this in green so you can see better exactly what I'm talking about. I'm going to talk about this triangle first, the green triangle. So if I can figure out the total distance, which I'm going to call Z, and then later I figure out this other distance, I can subtract to find Y. All right, so first I'm dealing with the 28-degree angle. From the 28-degree angle, the side opposite the 28-degree angle is my opposite side. The side touching the 28-degree angle is the adjacent side. So Z is the adjacent side. So again, I have tangent because it's opposite and adjacent. So I can do tangent, oh, I wrote theta. Tangent of 28 degrees. Whatever. Make this 28 degrees. I lost my white out. Well, I whited out. I messed up. I wrote the wrong thing. There it is. It's just supposed to say 28. There. All right. Tangent of 28 degrees equals opposite over adjacent. Its opposite is 650. Its adjacent is Z. Z is in the bottom, so Z and tangent will trade places. So I can solve. Z equals 650 divided by tangent 28. And as long as you're in degree mode, then you should get 1,222.472, and that is Z. I'm just going to circle that and save it for later, because I know I need to know the green one and then subtract this other one and it'll give me the pink one. So I'm going to do some other work. I found that value and I'm just going to hang on to it for a minute. Now I'm going to look at my other right triangle, the 52-degree triangle. So I'm going to look at this little one. No, we're really going to look at the purple one.
Okay.
All right, so 52 degrees for that triangle, the purple triangle. And we'll call this distance X. All right, so if we're at the angle 52 degrees, the side opposite of 52 degrees is still opposite. So I already called it opposite, it's still opposite. So this time X is the adjacent. So I'm going to do tangent again, but this time at 52 degrees equals 650 divided by X. Again, I'm solving for X. So X equals 650 divided by tangent 52. And if I type that in the calculator, if I'm in degree mode, I should get 507.8357. And that is going to equal X. When you're rounding, before you get to your final answer, you should always go one more decimal place than your final answer is supposed to be, so you don't lose any information when you round. So that's why I did 4 here. I probably should have done 4 decimals on that one also, but I didn't, so I'm not going to worry about it too much. All right, so now I have that length. I have the green length and I have the purple length. So I can say that Y is going to equal Z minus X. Okay, so Y equals 1222.472 minus 507.8357. And so y equals 714.636 feet. So to find the distance between the two, you need two different triangles. And if you want to write them separately, you can. You don't have to leave them in the same picture. If it helps you to do them side by side, do that. If you're fine with doing them in the same picture, you can do it that way. It's up to you. So your practice for today is page 228.
Question 39 through 53 odd.
Thank you. Numbers 39 to 53 odd. 4 of them are word problems. The rest of them are not. And you have a homework quiz tomorrow.
Oh. Is there any word problems on it?
Yes.
Oh. What will be your Friday?